Good day everyone, especially to you Ma'am Pisidas, and to our dear classmates, good morning. So, we are the Group 2 and we are the side reporter for this week. Can anyone still remember the last topic? Yeah, you're right. Last time, the Group 1 discussed all about the frequency distribution and graph. In this lesson, we will be discussing about the data description. Welcome, blessed math students, Group 2. Before we proceed to the lesson proper, let me present to you the objective. At the end of the class, we will be able to summarize data using measures of central tendency, such as the mean, median, mode, and mid-range. Describe data using measure of variation, such as the range, variance, and standard deviation. Identify the position of a data value in a data set using various measures of position, such as percentiles, deciles, and quartiles. Use the techniques of exploratory data analysis, including box plots and 5-number summaries to discover various aspects of data. So, measure of central tendency. The central tendency is stated as the statistical measure that represents the single value of the entire distribution or a data set. It aims to provide an accurate description of the entire data in the distribution. So, the central tendency of the data set can be found out using the 3 important measures. What are the 3 important measures in the central tendency? These are mean, median, and mode. 4. So guys, what is statistics? Can anyone tell about what is statistics? Yeah, you're right. A statistic is a characteristic or measure obtained by using the data values from a sample. So, what is a parameter? A parameter is a characteristic or measure obtained by using all the data values from a specific population. There are general rounding rules in statistics. The basic rounding rule is that when computations are done in the calculation, rounding should not be done until the final answer is calculated. For example, do you have an answer in the first step that kaya lang dili mo i-round off una ang imong basta dili pa ang final answer kay ini ka abot sa final answer budako ang iyang answer. So must be in the final answer you must be rounding off the final answer. And next is the mean. So what is mean? So the mean, is also known as the arithmetic average, is found by adding the values of the data and dividing by the total number of values. For example, the mean of 3, 2, 6, 5, and 4 is found by adding all the number equals 20 and dividing by 5. Hence, the mean of the data is 4 because 20 divided by 5 is 4. So, the values of the data represented by x in this data set. x1 equals 3, x2 equals 2, x3 equals 6, x4 equals 5, x6 equals 4. To show a sum of the total x values, the symbol like this. The capital Greek letter sigma is used means to find the sum of the x values in the data set. The mean is the sum of the values divided by the total of the values. The x bar represents the sample mean. So here is the formula of the x of the sample mean, where n represents the total number of values in the sample. For population, the Greek letter mu is used for the mean. This is the formula of the population, where capital N represents the total number of values in the population. So, murag nag-recall tadi kay nanan siya pag senior high sa statistics. So, the data, for example, the data represents the number of days off per year for a sample of individuals selected for 9 different countries. So, find the mean. So, mo ni ang mga data. 20, 26, 40, 36, 23, 42, 35, 24, and 30. So, ang ipangita ni is the sample. So, we use the barred X for the formula. So, barred X equals the summation of X over N. So, add all the data set and divide by 9. So, asa, manong divide na siya 9? Ang sum ng 9? So, muna ang pilas na kabuok nga data set. So, add the 20 plus 26 plus 40 plus 36 plus 23 plus 42 plus 35 plus 24 plus 30 equals 276 divided by 9. So, the answer is 30.7 days. Hence, the mean of the number of days is 30.7 days. Example number 3.3-2 is the hospital infection. The data show the number of patients in a sample of 6 hospitals who acquired an infection of hospitalized. So find the mean. So the data set is 110, 76, 29, 38, 105, 31. First, the formula that we use is the sample mean. Barred X equals the summation of X over small letter x. Add all the data set and divide it by 6. So, add the 110 plus 76 plus 29 plus 38 plus 105 plus 31 equals 389. Divided by 6. So, what is the answer? So, the answer is 64.8. So, the mean of the number of hospital infections for the 6 hospitals is 64.8. The mean in most cases is not an actual value. Rounding rule for the mean. So, rounding rule ang mean. So, the mean should be rounded to one more decimal place that occurs in the raw data. For example, if the raw data are given in whole number, the mean should be rounded to the nearest 10. If the data are given in tens, the mean should be the nearest hundreds, and so on. The procedure for finding the mean for group data uses the midpoints of the classes. The procedure is shown in text. So, using the frequency distribution, for example, 2-7, to find the mean. So, the data represent the number of miles run during 1 week for a sample of around 20 runners. So, solution. The procedure for finding the mean for group data is given here. Step 1. Make a table. So you must make a table for the class, frequency, midpoint, and f minus x. So here is the class 5.5 10 to 0.5 and so on. So the frequency is 1, 2, 3, 5, 4, 3, 2, a total of 20. Step 2. Find the midpoints of each class and enter them in column C. Unsa man pagkuha sa mga midpoints? So add the two class and then divide by 2. For example, 5.5 plus 10.5 divided by 2 equals 8. So the midpoint in 5.5 plus 10.5 is 8. Then another one is 10.5 plus 15.5 divided by 2. So the answer is 13 and so on. For step number 3, so get mo sa pagkuha sa midpoints. Okay. Step in number 3, for each class, multiply the frequency by the midpoint as shown and place the product in column D. So unsa pagkuha og sa aning column D? Simply is divide times 1 times 8 equals 8. Frequency times midpoint aron makakuha ta sa f minus x sa column D. So 1 times 8 equals 8, 2 times 13 equals 26, and so on. In step number 4, there is the completed table is shown here. The class, the frequency, the midpoint, and the column D. Step 4, find the sum of column D. So atong paon ang sum sa column D. Can you add all the numbers in the column D, and the answer is 490. Step 5, divide the sum by n to get the mean. So, x bar equals the sum of the x divided by n. So, the sum of the x is fx is 490 divided by pila ang n is 20. So, 490 divided 20 equals 24.5 months. So, the steps for finding mean for group data are summarized in the next procedure table. So, here is the procedure table to finding the mean of the group data. So, we proceed to the median. Diba, naka-agil na tayo mga mean, median, mode sa pag-grade 11 ba nga stats? Yes. So, what is median? Median is the midpoint of the data array. The symbol of the median is MD. So, here is the steps in getting the median. Step 1, arrange the data in order. So, dapat i-arrange na to una ang mga data in order from lowest to greatest. Step 2, select the middle point. Kung asa ang tunga, mo na ang median. So, for example, the number of rooms in the 7 hotels in downtown Pittsburgh is 713, 300, 618, 595, 311, 401, and 292. So, we find the median. First step, unsa ganito? Arrange the data in order. So, ang kinaganyan is 292. So then, next is 300, 311, 401, 595, 618, 713. So, nag-arrange siya na to. And then step 2, step 2, select the select the middle value. So, the middle value in this data set, data in order na is 401. So, the median in the number of rooms is the 7th, the median is 401 rooms. Another example, the number of tornadoes that have occurred in the United States over an 8-year period follows. Find the median. So, first step is ito sa mga number, i-arrange from lowest to greatest. So, we arrange the data. So, here is 656, next is 684, and the last is 1,303. So, ang kuan nila, ang midpoint is, gitungan is 764 and 856. So, unsaon man nato pakuha sa median kung silang nasa tunga ang ilang median. First, since the middle point falls halfway between 764 and 856. Find the median by adding the two values and dividing by 2. So, ang saan pakuha sa median kung ang median is nasa midpoint, sa middle point ni 764 and 856. So, i-add ang duha, then divided by 2. So, the median is 810. Nasabot? Okay. We proceed to the next topic is the mode. So, the third measure of average is called the mode. The mode is the value that occurs most often in the data set. It is sometimes said to be the most typical case. The value that occurs most often in the data set is called the, what is it? Mode. Okay, that's correct. If a data set has two values that occur with the same greatest frequency, both values are considered to be the mode, and the data set is said to be bimodal. If a data set has more than two values that occur with the same greatest frequency, each value is used as the mode of the data set is said to be multimodal. When no data value occurs more than once, the data set is said to have no mode. A data set can have more than one mode or no mode at all. Unsa ito nga kuan nga na siya if the data set has two values that occur with the same greatest frequency, unsa gyud siya? What is called bimodal. If the two values that occurs with the same greatest frequency, each value is used as a mode, what is it? A multimodal. For example, find the mode of the signing bonuses of 8 NFL players for a specific year. The bonuses in millions of dollars are 18.0, 14.0, 34.5, 10, 11.3, 10, 12.4, and 10. So, mas gusto agsa yun, dapat i-arrange mo siya in data in order. Aron mas dali makitaan ang mga mode. So, since ato siya i-arrange, so 10, 10, 10, 11.3, 12.4, 14.0, 18.0, and 13.4.5. Since $10 million occurred 3 times, a frequency larger than any other number, the mode is $10 million. So ang 10 million naman yung nagbalik-balik, so mo na siya ang mode. So, another example, find the mode for the number of branches that 6 bank have. 401, 344, 209, 201, 227, 353. Since each value occurs only once, there is no mode. Take note, do not say that the mode is 0. That would be incorrect because in some data, such as temperature, 0 can be an actual value. Take note that ha. And next is, the data show the number of licensed nuclear reactors in the United States for a recent 15-year period and then we find the mode. So there are 15-year period, there are number of licensed nuclear reactors. So 104, 104, 104, 104, and so on. So first solution, since the values 104 and 109 both occur 5 times, the mode are unsa mga modes na dire? Ang 104 and 105. So the data set is said to be bimodal. So ngayon na bimodal man siya. Kay duha ang modes niya. Next, the mode for group data is the modal class. So unsa itong o group data, it's called the modal class. So what is modal class? The modal class is the class with the largest frequency. So, for example, find the modal class for the frequency distribution of miles that 20 runners run in 1 week. Use in example 2-7. So, here is the class and the frequency. So, aris the frequency is ang 5 mo kina largest frequency. So, 5 is the modal class. Solution. The modal class is 20.5 minus 25.5. Since it has the largest frequency, sometimes the midpoint of the class is used rather than the boundaries. Hence, the mode could also be given as 23 miles per week. And that's all, and thank you.
Good day, everyone. I am Wendelin J. Kalolot, and I will be discussing some examples in finding the mode and mean. Also, I will be discussing mid-range, weighted mean, types of distribution, central tendency, its properties and uses, range, and the computational procedure. So, are you ready? Let's start! So, we have here the example of finding the mode, area boat registrations. So the data show the number of boats registered for 6 countries in southwestern Pennsylvania. Find the mode. So our data here is Westmoreland 11,008, Butler 9,002, Washington 6,843, Beaver 6,367, Fayette 4,208, and Armstrong, which is 3,782. The mode is the value that occurs most often in a data set. So we can see here in our data that Westmoreland appear the most since it has a frequency of 11,008. So our answer here, or our mode here, is the Westmoreland. We have here another example in finding the mean, median, and mode. Small salaries of personnel. A small company consists of the owner, the manager, the salesperson, and the 2 technicians, all of whose annual salaries are listed here. Assume that this is the entire population. Find the mean, median, and mode. So the owner's annual salary is $50,000. For the manager is $20,000. For the salesperson is $12,000. And for the technicians are both $9,000. We are tasked to determine what is the mean, the median, and the mode. In finding the mean, we will use the formula summation of x over n, where n is the total number of values in the population. We will determine our summation of x. We will add the values or all the data in the example. So we will add $50,000, $20,000, $12,000, $9,000, and another $9,000. And we will divide it by 5. So if we will get the summation of x, it would equal to $100,000. We will divide it by 5 since the total number of the values in the population is 5. And our mean here will be $20,000. Median would be $12,000 and our mode would be $9,000, which occurred the most often in a data set. As you notice, the mean is much higher than the median or the mode. This is because the extremely high salary of the owner tends to raise the value of the mean. In this and similar situation, the median should be used as the measure of central tendency. An extremely high or extremely low data value in a dataset can have a striking effect on the mean of the dataset. These extreme values are called outliers. This will be tackled by another reporter as we go further. So we have here another topic, which is the mid-range. The mid-range is defined as the sum of the lowest and highest value in the dataset divided by 2. Or in other words, the average of the lowest and highest values in the dataset. So the symbol MR is used for the mid-range. So we have here the example, water line breaks. In the last 2 winter seasons, the city of the Brownsville, Minnesota reported the numbers of water line breaks per month. Find the mid-range. So we have here the data 2, 3, 6, 8, 4, and 1. Our highest value here is 8 and our lowest value is 1. So we will add it. 1 plus 8 is equal to 9. We will divide it by 2 to find the mid-range. So 9 over 2 would equal to 4.5. So our mid-range here is 4.5. Another example, NFL signing bonuses. Find the mid-range of data for the NFL signing bonuses in example 3-9, which was tackled by Mr. Junilo. So the bonuses in millions of dollars are 18.0, 14.0, 34.5, 10, 11.3, 10, 12.4, and lastly is 10. So our smallest bonus here is $10 million and our largest bonus here is $34.5 million. So we will add it. $10 million plus $34.5 million would equal to $44.5 million. We will divide it by 2 to get the average. It would equal to $22.25 million. So our mid-range here is $22.25 million. Notice that the mid-range is larger than the 7 of the 8 amounts and it is unusual of the average of the bonuses. It is because there is one very high bonus, which is the $34.5 million. So we have here another topic, which is the weighted mean. Weighted mean is a type of mean that considers an additional factor. It is used when the values are not equally represented. So we have here an example, grade point average. A student received an A in English Composition 1, 3 credits, a C in Introduction to Psychology, which have 3 credits, a B in Biology 1, which have 4 credits, and a D in Physical Education, which have 2 credits. Assuming that A is equal to 4 grade points, B is equal to 3 grade points, C is equal to 2 grade points, and D is equal to 1 grade point, and F is equal to 0 grade point. Find the student's grade point average. Example, we'll find the weighted mean of a variable x. We'll use the formula summation of W times X over summation of W. So applying it to our example mentioned before, we will have 3 times 4 plus 3 times 2 plus 4 times 3 plus 2 times 1, which would equal to 32, and our over here our sum of our weight would be 3 plus 3 plus 4 plus 2, which would equal to 12. So 32 over 12 is equal to 2.7. So our grade point average here is 2.7. So we have here a table which contains the summary of measures of a central tendency. So we have here the properties and uses of a central tendency. First, we have the mean. So the mean is found by using all the values of the data. Second, the mean varies less than the medium or mode when samples are taken from the same population and all 3 measures are computed for these samples. The mean is used in computing other statistics such as the variance. The mean for the data set is unique and not necessarily one of the data values. The mean cannot be computed for the data in a frequency distribution that has an open-ended class. And lastly, the mean is affected by extremely high or low values called outliers and may not be the appropriate average to use in this situation. So the properties and uses of the median. The median is used to find the center or middle value of a data set. The median is used when it is necessary to find out whether the data values fall into the upper half or lower half of the distribution. The median is used for an open-ended distributions. And lastly, the median is affected less than the mean by extremely high or extremely low values. Properties of mode and its uses. The mode is used when the most typical case is desired. The mode is the easiest average to compute. The mode can be used when the data are nominal or categorical, such as religious preference, gender, or political affiliation. And lastly, the mode is not always unique. A dataset can have more than one mode, or the mode may not exist for a dataset. Properties and uses of a mid-range. The mid-range is easy to compute. The mid-range gives the midpoint. The mid-range is affected by extremely high or low values in a dataset. Types of distribution. So we have here 3 types of distribution. We have positively skewed or right-skewed, negatively skewed or left-skewed, and lastly, the symmetric. The positively skewed or right-skewed distribution, the majority of the data values fall to the left of the mean and cluster at the lower end of the distribution. The tail is to the right. Also, the mean is to the right of the median, and the mode is to the left of the median. For example, if an instructor gave an examination and most of the students did poorly, their scores would tend to cluster on the left side of the distribution. A few high score would constitute the tail of the distribution, which would be on the right side. Another example of a positively skewed distribution is the incomes of the population of the United States. Most of the income cluster about the low end of the distribution. Those with high incomes are in the minority and are in the tail at the right of the distribution. In a symmetric distribution, the data values are evenly distributed on both sides of the mean. In addition, when the distribution is unimodal, the mean, median, and mode are the same and are at the center of the distribution. Examples of symmetric distributions are the IQ scores and heights of adult males. When the majority of the data values fall to the right of the mean and cluster at the upper end of the distribution with a tail to the left, the distribution is said to be negatively skewed or left skewed. Also, the mean is to the left of the median, and the mode is to the right of the median. As an example, a negatively skewed distribution results if the majority of students score very high on an instructor's examination. These scores will tend to cluster to the right of the distribution. When a distribution is extremely skewed, the value of the mean will be pulled toward the tail. But the majority of the data values will be greater than the mean or less than the mean, depending on which way the data are skewed. Hence, the median rather than the mean is a more appropriate measure of central tendency. An extremely skewed distribution can also affect other statistics. That's the three most important distribution shape. We will now proceed in discussing an example in finding the mean, which is a bit complicated. Comparison of outdoor paint. A testing lab wishes to test two experimental brands of outdoor paint to see how long each will last before fading. The testing lab makes 6 gallons of each paint to test. Since different chemical agents are added to each group and only 6 cans are involved, these two groups constitute two small populations. The result in months are shown. Find the mean of each group. We have here the data of brand A and brand B. So we have 10, 60, 50, 30, 40, and 20. That is for brand A. Note that they are in months. So, for brand B, we have 35, 45, 30, 35, 40, and 25. So, in calculating for the mean of brand A, we will use the formula of in getting the mean, which is the summation of x over n. So, 10 plus 60 plus 50 plus 30 plus 40 plus 20, that would equal to 210. And our n here is 6 since we have 6 data values. So, 210 over 6 is equal to 35. Procedure for brand B, we will add 35, 45, 30, 35, 40, and 25. And we will get the value of 210. So, same procedure, we will divide it by 6. So that would equal to 35 months. So, the mean of the both brand is 35 months. Since the means are equal, we usually think that both brands of paint last equally well. However, when the data sets are examined graphically, a somewhat different conclusion might be drawn. Even though the means are the same for both brands, the spread of variation is quite different. For spread or variability of a dataset, 3 measures are commonly used: range, variance, and standard deviation. The range is the simplest of the 3 measures and is defined as the highest value minus the lowest value. the symbol R is used for the range. So for example, we will find the range of the comparison of outdoor paint. In brand A, we will have range is equal to 60 minus 10, since the 60 is the highest value in brand A and the 10 is the lowest value in brand A. So 60 minus 10 is equal to 50. So in brand B, the highest value there is 45 and the lowest value is 25. So 45 minus 25 is equal to 20. So the range for brand B is 20 and for the range of brand A is 50. For brand A shows that 50 months separate the largest data value from the smallest data value. For brand B, 20 months separate the largest data value from the smallest data value, which is less than 1/2 of brand A's range. So we have here another example for getting the range. Employee salaries. The salaries for the staff of the XYZ Manufacturing Corporation are shown here. Find the range. So the salary for the owner is $100,000. For the manager is $40,000. For the sales representative is $30,000. And for the workers, we have here $25,000, $15,000, and $18,000. So in getting the range, first we'll identify the highest value. So the highest value is the salary of the owner, which is the $100,000, and the lowest value is the $15,000, which is the salary of the worker. So $100,000 minus $15,000 would equal to $85,000. So our range here is $85,000. So since the owner's salary is included in the data, the range is a large number. To have more meaningful statistic to measure the variability, statisticians use measures called the variance and the standard deviation. So before we will introduce variance and standard deviation, we will tackle first the computational procedure, since its definition is derived from the procedure. For example, we will get the computational procedure of the comparison of outdoor paint. In step 1, we'll find the mean for the data. So mean is equal to summation of x over n. So we will add first the value in the variable x, or the data. We have here 10 plus 60 plus 50 plus 30 plus 40 plus 20. That would equal to 210. So our n is 6. So we will divide it. 210 divided by 6 would equal to 35. Step will be subtracting the mean from each data value. So our mean there is 35. So the data here is 10, 60, 50, 30, 40, and 20. We will subtract it each with 35. 10 minus 35 would equal to negative 25. 60 minus 35 would equal to positive 25. 50 minus 35 would equal to positive 15. 30 minus 35 is equal to negative 5. 40 minus 35 would equal to positive 5. And 20 minus 35 would equal to negative 15. Step would be square each result. So our result was negative 25, positive 25, positive 15, negative 5, positive 5, and negative 15. So we will square each. Negative 25 squared is equal to 625. Positive 25 squared is equal to 625. Positive 15 squared is equal to 225. Negative 5 squared is equal to 25. Positive 5 squared is equal to 25. And negative 15 squared is equal to 225. That would be to find the sum of the squares. So 625 plus 625 plus 1225 plus 25 plus 25 plus 225 would equal to 1750. Step would be to divide the sum by n to get the variance. So variance is equal to 1750 divided by 6. Our 6 was the n, which was the total number of the value of the entire population. So 1750 divided by 6 would equal to 291.7. The next step or the last step would be to take the square root of the variance to get the standard deviation. Hence, the standard deviation would equal to square root of 291.7 or the 17.1. It is also helpful to make a table. Here in table, the column A contains the row data x, column B contains the difference of x minus mean, and the column C contains the squares of the difference obtained in step 3. From computational procedure. First, the square root of the variance gives the standard deviation and vice versa. Squaring the standard deviation gives the variance. Second, the variance is actually the average of the square of the distance that each value is from the mean. Therefore, if the values are near the mean, the variance will be small. In contrast, if the values are far from the mean, the variance will be large. Maybe you're wondering why is the square distances are used instead of the actual distances. To answer that, it is because the sum of the distances will always be 0. You can verify this specific case by adding the values in column B of the table shown before. And when each value found in column B is squared, the negative signs are eliminated. Another wonder would be, why is it necessary to take the square root? So to answer that, since the distances were squared, the units of the resultant numbers are the squares of the units of the original data. Finding the square root of the variance puts the standard deviation in the same units as the row data. Remember, when you are finding the square root, always use its positive value since the variance and standard deviation of a data set can never be negative. So that's all for my report. This time, I want to conduct a game. That is to test if you really understood what my report is. The title would be Guess Me. You can comment down your answers. All. Thank you.
So, good day everyone, and I am here to report my assigned topics that were all about variance and standard deviation, sample variance and standard deviation, summary of measures of variation, procedure table, uses of the variance and standard deviation, coefficient variation, range rule of thumb, and lastly, Chebyshev's theorem. First, let's talk about variance. Variance is the average of the squares of the distance. Each value is from the mean. The symbol for the population variance is the Greek lowercase letter sigma nga nay exponent 2. So, this is the variance formula, where the x is the individual value, m is the population mean, and n is the population size. Then, let's talk about the standard deviation. It is the square root of the variance. The symbol for the population standard deviation is the lowercase letter sigma. Then, the standard deviation formula. Pare-pareha ni sila sa variance, ang kalahian lang nila na ay square root ang standard deviation. So, for example, find the variance and standard deviation for brand B paint. And the months were 35, 45, 30, 35, 40, and 25. So here is the solution. Step 1, find the mean. In finding the mean, atong isum up ang tanang value, then i-divide nato sa atong population size. So ang atong value mo ni siya 35 plus 45 plus 30 plus 35 plus 40 plus 25, i-divide nato sa population size nga 6. So, pag sum up na to ani, mao na siya ang nakuha, 210. Divide 6, that is equal to 35. Then, the next step is to subtract the mean from each value. Atong isubtract ang mean sa kada value. So, mao na siya ang result. 0, 10, negative 5, 0, then 5, then negative 10. Sunod, the next step is to square its result. Ang resulta sa pag-subtract nato sa value, ay sa mean sa kada value, mo na siya ang ato siyang i-square. So, step 3 is to square its result. Ang resultang sa pagkuha nato sa step 2 atong i-squared. So, next. So, maon ni ang resulta sa atong step 1, step 2, and step 3. Sa step 2, maon ni siya. Gi-minus nato sa kada value ang mean nga 35. Then, sa column C, atong gi-squared ang resulta sa column B. So, next. So, the next step is to find the sum of the squares in column C. Katong resulta sa table nga gipakita na ko ninyo sa column C, ato to siyang i-add. So, mo ni siya 0 plus 100 plus 25 plus 0 plus 25 plus 100 equals to 250. The next step is para makuha na to ang variance, atong i-divide ang na-sum up na to sa population size. So, mo na siya 250 divided by 6 is equal to 41.7. Lastly, take the square root to get the standard deviation. Singani ni siya. Square root of 41.7 is equals to 6.5. So, asa na itong gikuha ng 41.7, dili na siya gikan sa atong variance. Para makuha na to ang standard deviation, atong square root ang 41.7, mo to siya ni-equal siya sa 6.5. Therefore, the standard deviation is 6.5. So, moving forward to sample variance and standard deviation. So, this is the sample variance and standard deviation formula. Muna siya. Where the kining x is the individual value, dayon kining x nga naay linya sa baba mo na siya ang atong sample mean, dayon ang n mo na siya ang atong sample size. So, let's talk about shortcut or computational formulas for variance and standard deviation. The shortcut formula for computing the variance and standard deviation for data obtained from the samples are as follows. So, sa variance, mo na siya ang atong formula. Ang n, mao gyapon ni siya ang atong sample size, then ang x, mao siya ang atong value. Then, sa standard deviation, pare-pareha gyapon sa variance, Pero, naagyapon siya'y square root. So, let's have an example. Find the sample variance in standard deviation for the amount of European auto sales for a sample of 6 years shown. The data are in millions of dollars. So, ang atong value mo ni siya, 11.2, 11.9, 12.0, 12.8, 13.4, and 14.3. So, here is our solution. Step 1, find the sum of the values. Ang atong values mo ni siya, 11.2 plus 11.9 plus 12.0 plus 12.8 plus 13.4 then 14.3 ni come up sa 75.6. Then, square each value and find the sum. So, ang kada value atong i-square, dayon atong i-add. Mo na siya ni come up og 958.94. Then, substitute in the formulas and solve. So, 6 times 958.94 minus 75.6 squared divided by 6 times 6 minus 1. So, kining 6, mo na siya ang atong n nga sample size. Kining 958.4 mo na siya ang atong result sa pag-square then gi-add. Then kining 75.6 squared mo na siya sa pag-add-on nato sa values. Gi-squared nato. So atong i-solve. 6 times 958.94 ni come up sa 5,753.64. Then minus the squared of 75.6 ni come up sa 5,715.36. Then kining 5 aton siyang gikuha sa n-1 which is 6 minus 1. Ato na siyang i-times, mahimo na siyang 30. Then 5,753.64 minus 5,715.36 is equal to 38.28. 6 times 5 mo na siya ang 30. Ato na siyang i-divide, mahimo na siyang 1.276. Then, ang variance atong i-round off, mahimo siyang 1.28. So, sa pagkuha nato sa standard deviation, atong kwaon ang squared para makuha nato ang standard deviation. So, the square root of 1.28 is equal to 1.13. Hence, the sample standard deviation is equal to 1.13. So, note that the sum of the square first score is not the same as the sum of the score squared. This notation means to square the values first, then sum. So, kini kuno nga notation, atong i-square una ang values before nato i-add. Then, kini nga notation means to sum the values first, then square the sum. So, kini siya pasabot ane, i-add nato tanan values, then atong i-squared. So, let's talk about the variance and standard deviation for group data. The procedure for finding the variance and standard deviation for group data is similar to that for finding the mean for group data, and it uses the midpoint of each class. So, ang pagpangita sa variance and standard deviation sa group data, pare-pareho ra sa papangita sa mean sa group data. Dayon, nagamit na sila og midpoint sa kada class. So here is the summary of measures of variation. The measures are range, variance, standard, and standard deviation. And there is their definition and symbol. So the definition of range is the distance between highest value and lowest value. And mao na ang iyang symbol R. Variance is the average of the squares of the distance that each value is from the mean. Mao na siya ang symbol, ang sigma of S. Then standard deviation is the square root of the variance. Mao ni siya ang symbol sa standard deviation. So, naatay procedure diri para makuha nato ang sample variance and standard deviation for group data. Step 1, make a table and find the midpoint of each class. So, muna ang imong entry sa upper part tapit sa imong table. Then, step 2, multiply the frequency by the midpoint for each class and place the products in column D. So, ang frequency ang midpoint atong i-times or multiply then atong imutang sa column D. Step 3, multiply the frequency by the square of the midpoint and place the products in column E. I-multiply ko na nato ang frequency o ang na-square nga to nga midpoint. Squared nga midpoint. Mo na siya. Then atong ibutang sa column E. Step 4, find the sum of column B, D, and E. Then step 5, substitute in the formula and solve to get the variance. Mo na siya ang atong formula sa pagkuha sa sample variance. Dayon, take the square root to get the standard deviation. So, sunod. So, let's have an example. So, find the variance and standard deviation for the frequency distribution of the data. In example 2 to 7, the data represent the number of miles that 20 runners run during 1 week. So, mao na siya ang atong data. Then, ang class mao na siya 5.5 to 10.5, 10.5 to 15.5, and so on. Frequency mo na siya ang kadaghanon sa runners nga nikuan sa class. Then, ang midpoint, makuha na to ang midpoint by adding the class 5.5 plus 10.5, then divide it to 2. Mo na siya ang midpoint. Here is our solution. So, di ba giingon na sa procedure nga make a table as shown. Then, atong pangitaon ang midpoint sa kada class. Then, gihatag naman ang kada midpoint, proceed ta sa second nga step. Multiply the frequency by the midpoint for each class and place the products in column D. So, atong i-multiply ang frequency nga 1 sa midpoint nga 8. So, makuha na siya, ma-equals na siya sa 8. Then, 2 times 13, 26, and so on. Then, multiply the frequency by the squares of the midpoint and place the products in column E. So, ang multiply nato nga frequency og midpoint atong squared. Then, ang products nga nakuha nato atong ibutang sa column E. So, atong makita ang table nga naa tanan data. So, sa pagkuha nato sa column D, atong gi-multiply ang frequency og ang midpoint. Then, sa pagkuha nato sa column E, atong gi-squared ang product sa column D. Product sa frequency og ang midpoint atong gi-squared. So, atong gi-sum up ang column D ni equal siya sa 490. Then, atong i-sum up ang column E ni equal siya sa 13,310. Then, ang next step, ana, is atong i-substitute para makuha na to ang variance. Mao na siya ang formula. Then, 20 times 13,310 minus 490 squared over 20 times 20 minus 1. So, asa nato na siya gikuha? Mo man siya ang atong formula, di ba? So, ang 20, mo na siya ang n nga sample size. Ang sample size nato adto moonto ang mga runners. 20 sila. Then, kining 13,310, ari nato na siya gikuha sa column E. Dayon, kining 490, mo na siya ang sa column D, then ato siyang squared. So, maura gyapon ani, mo na siya ang atong sample size, then gimaynusan og 1. So, atong i-times ang 20 times 13,310 nga ni-come up sa 266,200. Then, ang 490 squared, ni-come up siya sa 240,100. Then, kini, atong i-minus ang 20 minus 1, ni-come up siya og 19. So, ato siyang isolve. 266,200 minus 240,100 is equal to 26,100. Then, 20 times 9, ni-come up siya sa 380. Para ato siyang makuha na to ang variance, ato yung i-divide. Yan, equal siya sa 68.7. Sunod na atong kwaon or atong pangitaon ang standard deviation. So, maorag yapon na pamaagi sa previous nga topic nako. So, atong kuha ang square root sa variance. So, square root of 68.7 is equal to 8.3. So, mao na siya ang atong standard deviation. So, let's talk about the uses of the variance and standard deviation. So, first, as previously stated, variances and standard deviation can be used to determine the spread of the data. If the variance or standard deviation is large, the data are more dispersed. This information is useful in comparing two or more data sets to determine which is more or most variable. Then, the measure of the variance and standard deviation are used to determine the consistency of a variable. For example, in the manufacture of fittings, such as nuts and bolts, the variation in the diameters must be small, or the parts will not fit together. Then, the variance and standard deviation are used to determine the number of data values that fall within a specified interval in a distribution. For example, Chebyshev's theorem shows that for any distribution, at least 75% of the data values will fall within two standard deviation of the mean. This will be explained later. Finally, the variance and the standard deviation are quite often in inferential statistics. So, moving forward to coefficient of variation. So, coefficient of variation. The coefficient of variation is denoted by CVR. The standard deviation divided by the mean. The result is expressed as a percentage. So, muna siya ang formula para sa sample. Then, kinipod para sa population. Kining S, muna siya ang standard deviation. Then, ang X, muna siya ang mean. So, let's have an example. So, muna siya ang atong example. Sales of automobiles. The mean of the number of sales of cars over a 3-month period is 87, and the standard deviation is 5. The mean of the commissions is $5,225, and the standard deviation is $773. Compare the variations of the two. So, muna siya atong solusyon. The coefficient of variations are, so, ang S nato sa sales mao ang 5. Standard deviation nato 5. Then ang atong mean mao ang 87. So 5 divides 87 times 100 ni equal siya 5.7%. Mao siya ang sales. Then atong isolve pod ang sa commission. So ang standard deviation niya is 773 divided by the mean mao siya ang 5,225 times 100 ni come up siya sa 14.8%. So mao siya ang sa commission. Since the coefficient of variation is larger for commissions, the commissions are more variable than the sales. So let's talk about the range rule of thumb. The range rule of thumb. The range can be used to approximate the standard deviation. The approximation is called the range rule of thumb. A rough estimate of the standard deviation is siya. Standard deviation equals to range over 4 or divided by 4. So, for example, the standard deviation for the data set 5, 8, 8, 9, 10, 12, and 30 is 2.7. So, giunsa man nato pagkuha ning 2.7. Inganin siya. Gamit ang standard deviation formula, atong gi-substitute. 7 times 647 minus 4,225 divided by 7 times 7 minus 1. So, kining 7 muna siyang atong sample size. Kini siya. Kini. Dayon kining 647 muna siya ang kanang atong gi-square ang kada value then atong gi-sum. So, muna siya nakuha siya og 647 minus 4,225 muna siya ang gi-add na to una ang kada value then atong gi-squared. So muna siya ang digawas nga answer 4,225. Then dayon kining 7 mo gyapon na siya ang sample size. So ato na siyang i-minus 1. So sa pag-solve na to ani ni come up siya sa 300 over 42. 300 divided by 42 is equal to 7.14. Muna siya ang atong variation. Then, so standard deviation man ato gipangita, ato na siyang kwaon nato na ang square root. So, square root of 7.14 is equal to 2.7. Muna siya. So, ang range, ano siya? Sa pagkuha nato sa range, highest value minus the lowest value. So, muna siya. 13 minus 5 equals to 8. Dayon, the range rule of thumb is 2. So, nganong 2 man. Kaya ang atong standard deviation is ang range divide sa 4. So, mo na siya ni come up siya og 2. Mo na siya ang the range rule of thumb. Mo na siya. Last na ko nga topic is all about Chebyshev's theorem. So, unsa man ni siya? It is the proportion of values from a data set that will fall within K. Standard deviation of the mean will be at least 1 minus 1 over K squared, where K is a number greater than 1. K is not necessarily an integer. It applies to any data set. At least 3/4 of the observation in any data set will fall within 2S. 2 standard deviation of the mean. Ngani. So for example, a survey of local companies found that the mean amount of travel allowance for executives was $0.25 per mile. The standard deviation was $0.02. Using Chebyshev's theorem, find the minimum percentage of the data values that will fall between $0.20 and $0.30. Ano siya ang solusyon? Step 1, subtract the mean from the larger value. So, ang larger value ato nila is katong $0.30 minus the $0.25 equals to $0.05. Then, step 2, divide the difference by the standard deviation to get K. Then, mo na siya. 0.05 divided by 0.02 is equal to 2.5. Then, atong gamiton ang Chebyshev's theorem para pangitaon ang percentage. So, 1 minus 1 over k squared is equal to 1 minus 1 over 2.5 squared. Then, himo siyang 1 minus 1 over 6.25 kay squared man ang 2.5. So, yung ano yung ni-come up. I-divide na to ang 1 divided by 6.25 himo siyang 0.16. 1 minus 0.16 is equal to 0.84. Then, percentage man natong kuha. So, atong i-times 100 nahimo siyang 84%. Hence, at least 84% of the data values will fall between $0.20 and $0.30. So that would be all. Thank you.
And this is the continuation report of our topic, which is the data description. So, I will be presenting the empirical rule, the z-score or standard score, and percentile. Our learning objectives at the end of the lesson, students should expected to define what is empirical rule, z-score or standard score, and percentile. Determine the formula for each topic, solving and making graphs to the situational problems given for each topic. So first is that the empirical rule. I know that some of you here is already familiar of this one, no? Especially to those STEM students. They already encounter this in their statistics and probability. But anyways, sa katong wala pa, don't worry because learning has no limitation. Limitation, walay boundaries, and walay deadline. But anyways, let us focus on our empirical rule. Empirical rule applies to a normal or bell-shaped distribution. So, kaning empirical rule is that Chebyshev's theorem applies to any distribution regardless of its shape. However, when a distribution is bell-shaped, following statement which make up the empirical rule is true. So this is our illustration of our empirical rule. Approximately 68% of the data values will fall within the one standard deviation of the mean. So one standard here and here, this is our 68%. Approximately 95% of the data values will fall within two standard deviation of the mean. Here and here is our 95%, and approximately 99.7% of the data values will fall within 3 standard deviation of the mean. Here and here is our 99.7. So
here is the overall illustration of our empirical rule. The left side, which is 50%, and right is 50%, overall 100%. So, what is this class? So, first in here, this is our 68%, ganong na 34 naman na siya. Of course, ato siyang gi-divide into 2. And here, ganong na 13.5% na naman ni siya, ma'am. Of course, ang atong 95 atong gi-divide og 2, which is the 47.5. And our 47.5 atong gi-minus aning 34. And mo ni siya ang atong result, 13.5. And lastly, our 99.7, nganong na 2.35 naman lang ni siya, ma'am. Of course, ang atong 99.7 atong gi-divide og 2, and ang result is 49.85. So, ang atong 49.85 class, atong gi-minus sa 47.5 dere. So, mao na lang ni siya ang nahabilin, 2.35. So, ato ani siyang i-calculate tanan, ato ni siyang i-add tanan, it will come up into 100%. But here, napa ni siya 0.15% para ma 100% yun siya. But anyways, no, dili na ako mag-dig deeper ani because it will be more tackled in chapter 6 man class. So let us proceed to the z-score or standard score. So there is an old saying, class, na you can't compare apple and orange, but with the use of statistic, it can be done in some extent. So, this comparison uses the mean and standard deviation, and it is called z-score or standard score. So, our standard score, no? For a value is obtained by subtracting the mean from the value and dividing the result by the standard deviation. So, this is the formula of our z-score or standard score, which means that the x is the value, the x bar is the mean, and s stands for standard deviation. But if our problem class is population, muna siya ang gamito nato nga formula. So let us proceed sa atong example, no? Para mas makasabot pag ito ani og unsaon ni paggamit si z-score or standard score. So, a student scored 65 on calculus test, and that had mean of 50 and standard deviation of 10. Muna siya iyahang kuan sa calculus. And on the other hand, she scored 30 on a history test with a mean of 25 and standard deviation of 5. So, in this problem, compare her relative position on the two tests. Masarag itong two tests, ang calculus test o ang history test. So first, let us solve the z-score of calculus test. So first, find the z-score on the calculus. So, ang atong formula, which is this, and substitute, no? Substitute the value of x, which mean, our value is 65, our mean is 50, and our standard deviation is 10. So, ang atong z-score sa atong calculus is 1.5. On the other hand, our history test and z-score is substitute the formula, no? And solve. 30 minus 25, 30 is the value, 25 is the mean, and 5 is the standard deviation. And atong history test is 1. So, sa atong problem gani, compare her relative position. So, asa may much bigger ani? Of course, the calculus. Kaya ang calculus nato, class, is 1.5. And our history is only 1. So, since the z-score for the calculus is larger, her relative position in the calculus class is higher than her relative position in the history class. So, nag-gets ba, class? Of course, easy ra na, oy. Gets kayo. So, og mas makasabot pag ito no na pag ito another example. So, in this table, task A and task B. And gihatag na ang atong mean, value, and standard deviation. So, find the z-score for each test. Task A and task B. And state which is higher. So, first, let us solve the z-score of test A. So, substitute. Our value is 38. Our mean is 40. And standard deviation is 5. So, solve. Ang atong test A, ang z-score niya is negative 0.4. So, proceed ta sa atong test B. Solve the test B z-score. Z-score of test B, sorry. So, substitute again, class. Our value is 94. Our mean is 100. And standard deviation is 10. So, solve. Negative 0.6. So, which is higher? Ang 0.4, negative 0.4, or negative 0.6? Of course, ang test A, which is the negative 0.4. Therefore, the score for test A is relatively higher than the score for test B. So now, nagets ba, class? Yes, uy! So now let us proceed to the percentile. So what is percentile, ma'am? Percentile are position measures used in educational and health-related issues, health-related fields, to indicate the position of an individual in a group. So, gamit ang percentile, class, no, sa atong educational and health-related fields. So, percentile, muna siya mag-divide sa dataset into 100 equal group. So, in this illustration, first is in the left side, no? This shows the percentile rank and skill score on the test of English as a foreign language. If a student had a skill score of 58 for a section 1, which is the listening comprehension, the student would have a percentile of 81. And hence the student did better than 81% of the student who took the section 1 of the exam. So in the right side, class, no? This percentile in graphical form of weights of girls ages from 2 to 18. And to find the percentile rank of an 11-year-old, so ang atong x-axis is which is the age, and our weight is in the y-axis. So supposed to be to find the percentile rank of an 11-year-old girl who weighs 82 pounds. So 11 the rayong age and iyang weight is 82. Start that at the 82 pound on the left axis and move horizontally to the right. So, kani siya, ito siya itupong, class. Then, find 11 on the horizontal axis and move up. The two lines meet at the 50th percentile. So, 50th. Wala man siya, no? 50th percentile of her age group. So, if the line do not meet exactly in the curved percentile, which is here, so, the percentile rank must be approximated. So, if ang line kuno kadili mag-meet up, so, ang atong percentile rank must be approximated. So, class, take note ha nga, percentile are not the same as percentage. Percentile are symbolized by P sub 1 to P sub 99. And divided the distribution into 100 group from smallest data to largest data value. So of course no, di jud ta kasabot aning mga yaw-yaw ra og dili nato i-apply. So na jud ta example ani no, just like what I've said earlier class nga ang percentile can be done in education and health related fields. So, kaning systolic blood pressure, man siya ang health-related field na to. So, in this example, the frequency distribution for the systolic blood pressure readings of 200 randomly selected college students is shown here. So, ang atong problem no is construct a percentile graph. So, naman tayo 200 selected college, randomly selected college. So, in this table, magama ta og class boundaries. Kabaw na taon sa ni paggama, no? Kaya ginatakod na ni sa previous chapter. So, class boundaries, frequency, as well as the cumulative frequency and kaning cumulative percent. So, solution. Step 1. Find the cumulative frequency and place them in column C. Column C, here. Kay ba naman taon sa ni pagkuha ni cumulative frequency class no, kay kuha naman ni siya pag previous topic. So 0 plus 24 equals, where's my mouse? 0 plus 24 equals 24, 24 plus 62 equals 86, 72, 58, 158 plus and so on and so forth, and it will sum up into 200. No? So step 2, find the cumulative percentage and place them in column D. So kanina no, unsaon na to pagkuha si cumulative percent. So to find this, ay to solve this cumulative percentage no, nagyutay formula. So cumulative percentage equals cumulative frequency, which is here, and the total number of cumulative frequency, and it times na to sa 100. So supposed to be our cumulative frequency is 24 and overall is 200. So 24, substitute 24, 200 and times it by 100, multiple it by 100. Sorry class. And it will come up into 12%. And same process gapon siya no, 24 si 24, si 86, si 158. Nga na yun siya pag-process class. So, if atong 24 is, atong cumulative frequency is 24, then 12%. But, I realize class, na, pwede na siya i-divide na to 2. No? 24 divide 2, 12, 86 divide 2, 43. 158 divide 2, 79. 184 divide 2, 92. 196 divide 2, 98. And 200 divide 2 is 100. So, nga na ang easier way, no? Once a percentile graph has... So, ang ato ang problem man ani kay construct a percentile graph, no? Na naman tayo cumulative frequency and cumulative percent. So, ang atong graph na atong gamuan. So, supposed to be the y-axis is our cumulative percentage and our x-axis is the class boundaries. Once a percentile graph has been constructed class, one can find the approximate corresponding percentile for a given blood pressure value and find the blood pressure values for a given percentile. So, for example, no, to find the percentile rank of a blood pressure reading of 130. So, asa man ang 130 na to dire class? Here. Kung dili po dire no, kay 134 naman eh. So, dire 130. Find 130 on the x-axis and draw a vertical line on the graph. So vertical line here and then move horizontally to the y-axis. Note that the blood pressure of 130 is correspond to approximately 70th percentile. So here and to here 70. So inga na siya kas, no? So if the value nato is 40 percentile, 40th percentile, here. So start on the y-axis at the 40 and draw horizontal line to the graph. Then draw a vertical line on the x-axis and read the value. So if our 40th here, down to here, which is the 118. So nga nang nag 10-20 man ta class, kay lisod man pod, no, og ato ara siyang iingani og form, then mura na siya line good ang forma. Mas nindot gud to og ato ni siyang i-order bitaw para makita gud nato og unsa ang flow. Nagets ba class? Gets? Uy! So now let us proceed to percentile formula. The percentile corresponding to a given value x is computed by using the following formula. So if mangita ta sa percentile class, mo na siya ang gamito nato nga formula. Number of values below x and total number of values times, napa ni siya ikuan class, sorry ha, napa ni siya plus 0.5, but anyways, given naman ni siya here, manilang 0.5. So example 3.1. So para ma-apply ni nato ang percentile formula, no, maghatag yung example. So supposed to be a teacher give a 20-point test on 10 students. The score are shown here. So find the percentile rank. Again, find the percentile rank of the score 12. So ang step good ani, no, kay i-arrange good ni siya into this. And 10 man ni siya kabok. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And use the formula. Percentile equals number of values below x plus 0.5 over total number of values times 100. So percentile rank of score 12 man class. So 12 here. And ang atong number of values below x is, if magkuha sa number of value below x, ato ra siyang i-divide og 2, which will come up into 6, and i-plus na to sa 0.5, i-divide na to siya sa 10 times 100. So ang atong percentile rank of the score 12 is 65th percentile. Thus a student who scored 12 did better than 65% of class. So another example, no, para mas makasabot pagid ta. So using the data gihapon natong gamit dere, kanira gapon tong gamiton, pero another example na sad para mas makasabot kita. So now find the percentile rank for a score 6. So ganina if score is 12, karon atong another problem is 6. So solution, no, use the formula. And ganun 3 naman ni siya class. Of course, atong gi-divide og 2. And 3 na siya. Plus na to og 0.5. And divide 10. 10 is na number of total number of values. I-times na to sa 100 and it will come up into 35th percentile. So a student who scored 6 did better than 35% of class. So, nag-guess ba, class? Nag-guess, uy! So, no? Proceed na to sa another example. And, kani example is, ang data gihapon natong gamiton is, sa kinanahan na to nga data, which is kani gihapon tong gamiton nga data, class. Pero another example, nasad ni siya, no? Find find the value. As ang ganina is find the percentile rank. So karon, find the value of corresponding to the 25th percentile. So given na ang percentile, no, ang atong pangitaon na pod is value. So of course nagitay formula ana, no, kung saan pagkuha, where n is the number of values and p is stand for percentile, and over 100 class. So substitute 10 number of values, total number of values, 25 is the percentile, and divide it by 100. So it will come up into 2.5 or 3. So class, no, if atong value is dili whole number, ato na siyang i-round up to the whole number. G. So another example na sad, no, para mas makasabot pa gyud ta, pero same gihapon ni siya. Pangitaon nato is value gihapon, and ato ang data nga gamiton is ang sa value sa example 3.1. So step 1 again, arrange the data, then solve. Kani atong gamiton kay value man ang gipangita. So use this formula, then substitute 10, which is the number of total number of values, 60, which is the percentile, 100 is the given. So 10 times 60 is 600 over divide 100 is 6. So step 3, no, if C is whole number, use the value halfway between the C and C plus value when counting up from the lowest value. So in this case, no, the 6th and 7th value. So asa man ang 6th and 7th value ani class? 1, 2, 3, 4, 5, 6, 7. So atong 6th and 7th value is 10 and 12. So the value between the 10 and 12 is 11. Kay ang 10 atong gi-plus sa 12 and atong gi-divide og 2, and muna siyang na 11 na siya. Gets ra class? So muna siya ang procedure table, no, basta magkuha ta sa data value. So that ends with my topic, class. Thank you for listening. I hope you learned, and for the next topic it will be discussed by Mr. Bano. Thank you guys, and God bless.
Good day everyone, I am John Bano, one of the reporters for today's discussion, and this is just a continuation of the topic, data description. And I guess we already learned about quartiles and decils way back in high school, so do you have any idea of what is quartiles? Quartiles divide the distributions into 4 groups separated by Q1. The first quartile, second quartile, and third quartile. Take a look at the figure below. We can see that the distribution is divided into 4 groups equivalent to 25% each. Take note that the data set must be arranged from lowest to highest value. See, for example, we have a data set of 3, 1, 2, 4, 5, 8, 7, 9, 6, and 10. First thing that we need to do is to arrange, as what I have said earlier, in increasing order. So our data set would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Example, find first quartile, second quartile, and third quartile for the data set 15, 13, 6, 5, 12, 15, 22, 18. Our minimum, so a first step is to arrange data in order from lowest to highest. Based on the given set, our minimum value is 5 and our maximum value is 50. So the set would start with 5, followed by 6, 12, 13, 15, 18, 22, and lastly 50. Step 2 is to find the median or the value of the second quartile. So since the total of values is even, we need to add the two values and divide it by 2 to come up with a median of 14. So step 3 is to find the median of the data values that are less than 14. So what are the values that are less than 14? It includes 5, 6, 12, and 13. So to solve for the first quartile, same with itong nangita ta sa median of which is the second quartile. Ato iya pong i-add ang two values and divide it by 2. So our first quartile is 9. Step 4 is to find the median of the data values greater than 14. So what are the values that are greater than 14? 15, 18, 22, and 50. So same thing gihapon, atong gyapon i-add ang two values and divide it by 2 to make it to find for the third quartile, which is 20. Therefore, our first quartile is 9, second quartile is equals to 14, and third quartile is equal to 20.
Your remarks, we can use the formula given for computing the percentile in solving for the quartile. If you could still remember, C is equals to N times P all over 100. Take note that first quartile is equal to the 25th percentile. Therefore, we could use P equals 25 when solving for the first quartile, 50 for second quartile, and 75 for third quartile. However, there is an easy way in which we can solve for the quartile. Step 1 is to arrange the data in order from lowest to highest, or like for example, we have a data set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Our minimum is 1 and our highest value is 10. Step 2 is the find the median of the data values. This is the value for second quartile. Take note that, just like what I have said earlier, if the total number of the data set is even, we must add the two values and divide it by 2 to come up with the median. Step 3 is we need to find the value for the first quartile, which is the median of the data values that falls below Q2. Kung unsa to may mga values that are lower than the second quartile of the 50th percentile. Step 4 is to find the median of the data values that falls above Q2. This is the value for third quartile. Next is the IQR, or termed as the interquartile range. The interquartile range is defined as the difference between the first quartile and third quartile, and is the range of the middle 50% of the data. It is used to identify outliers, and it is also used as a measure of variability in exploratory data analysis. So, what do you mean by outliers, or do you have any idea about it? It is the value that is extremely high or low, sobraan labi to kagamay or kadako compared to other values. Murag wa na siya mo fit sa data set. We will talk about more about outliers and exploratory data analysis as we go along the topic. So this is an example on how to find for the interquartile, how to solve for the interquartile range. Next is the decile. So what is decile? Decile divides the distributions into 10 groups. They are denoted by D sub 1, D sub 2, and D sub 3, and so on. Same thing as what we did in finding quartiles. You can also use the formula given by finding the percentile if we will solve for the decile. It's just that it varies in terms of the distributions of the data set, since our decile would be divided into 10 groups. Take note that the median is the same as 50th percentile, 2nd quartile, and 5th decile. Next is the outliers. Again, an outlier is an extremely high or an extremely low data value when compared with the rest of the data values. Like for example, a data set values of 1, 2, 3, 4, 5, 6, 7, and 20. What do you think is the outlier? Which among the data set is extremely suspect? Diba, ang 20 kay dakura kaayo compared to the other values. So these are the methods in checking for outliers. Step 1 is to arrange the data in order and find first quartile and third quartile. Step 2 is to find the interquartile range. Step 3 is to multiply the interquartile range by 1.5. Next is subtract the value obtained in step 3 from first quartile and add the value to third quartile. Check the dataset for any data value that is smaller than first quartile minus 1.5 times interquartile range, or larger than the third quartile plus 1.5 times the interquartile range. So for a better understanding, take a look at this video.
And to create a modified box plot. So here's a standard box plot that utilizes this 5-number summary from this data. So outliers are numbers that are outside the group of the rest of the data. So right here is the data. This 3 might be a little too low when compared to the rest of the data, or this 34 might be a little too high when compared to the rest of the data. So what we're going to do is figure out if the 3 or the 34 or any of the other numbers actually qualify as outliers. To do that, we use something called the 1.5 interquartile range rule. So the interquartile range can be calculated by taking quartile 3 and subtracting quartile 1 from it. And then we're going to multiply that by 1.5. So let's start with that. 1.5 IQR is 1.5 times quartile 3 minus quartile 1. So that equals, quartile 3 is 18, quartile 1 is 13.5, and that whole thing turns into 6.75. Now what we do with this value is we subtract it from quartile 1 to look for lower outliers. So quartile 1 is 13.5. 13.5 minus 6.75 is 6.75. So if we have any values less than 6.75, it's going to be considered a low outlier. So I'm actually going to put that 6.75 on our plot. That's about right here. Now what we see is we do have values that are lower. So it turns out that, yeah, this 3 is a lower outlier. Here's how you modify the box plot. Replace the outlier with an asterisk. So the 3 is now an asterisk. And our lowest value that's not an outlier is 12. So that's going to become our new end of our whisker. And we'll get rid of that. What we've done is just modified the box plot. But we have to do the same thing for upper outliers. So to determine if there's any upper outliers, we take quartile 3 and add 1.5 times the interquartile range to it. So since quartile 3 is 18, 18 plus 6.75 is 24.75, which is right here. And we see, yeah, we do have values that exceed that boundary line. So the 34 is also an outlier. It's an upper outlier. So we need to modify the box plot again. Replace the 34 with an asterisk. Our highest value that's not an outlier is this 19. And erase the whisker. And now we have a modified box plot where we have outliers clearly identified.
It's very important to determine the outliers of the dataset because it could affect the mean and the standard deviation. It can affect in a way that it could make the values larger than it should be. Can you think of a reason why outliers occur? Perhaps there's some error while taking the measurement or observations, or it could be when recording the data, a researcher might type the value incorrectly. If you have something to add, just comment right out. Just comment right after watching this video.
Exploratory data analysis. In traditional statistics, data are organized by using a frequency distribution. From this distribution, various graphs such as the histogram, so we have already discussed about histogram from previous discussion, frequency polygon, and ogive that can be constructed to determine the shape or nature of the distribution. In addition, various statistics such as the mean and standard deviation can be computed to summarize the data. The purpose of traditional analysis is to confirm various conjectures about the nature of the data. See, for example, from a carefully designed study, a researcher might want to know if the proportion of Americans who are exercising today has increased from 10 years ago. This study would contain various assumptions about the population, various definitions such as of the exercise, and so on. In exploratory data analysis, or EDA, data can be organized using a stem and leaf plot. The measure of central tendency used in EDA is the median. The measure of variation used in EDA is the interquartile range. The third quartile is second quartile. In EDA, the data are presented graphically using a box plot, sometimes called the box and whisker plot. The purpose of exploratory data analysis is to examine data to find out what information can be discovered about the data, such as the center and the spread. Exploratory data analysis was developed by Jan Doki and presented in his book Exploratory Data Analysis. So there is actually a difference between traditional statistics and exploratory data analysis. The 5-number summary and the box plots. A box plot can be used to graphically represent the data set. This plots involve 5 specific values. So this specific values is called the 5-number summary. That includes the lowest value of the data set is the minimum, the first quartile, the median or the second quartile value, the third quartile, and lastly the highest value of the data set, which is the maximum value. Procedure for constructing a box plot. Find the 5-number summary for the data values, that is the maximum and minimum data values, first quartile and third quartile, and the median. Draw a horizontal axis with a scale such that it includes the maximum and minimum data values. Draw a box, vertical sides go through use of first quartile and third quartile, and draw a vertical line through the median. Draw a line from the minimum data value to the left side of the box and a line from the maximum data value to the right side of the box. So this is what we call the box plot.